So by way of explanations as to why one atom would have a larger or smaller radius than the other, I have some examples here. And let's start with a comparison of calcium and magnesium. Now the first thing you should consider in terms of radius or any other periodic property is what the valence level is for the atom. And that's as simple as looking at the periodic table. For any neutral atom, its valence level is the same as its period. So yes, calcium has a valence level of n equals 4. That's where its farthest electrons are found. But magnesium actually has a lower valence level of 3. Therefore, if we're going to say who has the larger radius, who has the greater distance from the center of the nucleus to the valence level electrons, well, that has to go to calcium. And a good way to explain it would be to write, due to the fact that calcium has a higher valence level, and of course quote the number. Tell the reader you know something about the atoms in the periodic table. Compared to magnesium's n equals 3 valence level, the radius of calcium is greater than that of magnesium. End of story. Clean and simple. Now, what if we are trying to instead compare the radius of aluminum, I guess I need a different color here, and that of sulfur? Well, without giving away the farm, which I already have, I do some consideration. First, I realize that aluminum is in period 3 and sulfur is also in period 3, so they both have n equals 3 as a valence level. That's no good. That's not going to help me explain a difference in radius. However, the second thing to look at if you eliminate valence level as an argument is the effective charge of each atom. Being in group 3, aluminum has a +3 effect on its valence electrons, whereas sulfur has a greater +6 effect as a group 6 atom. Now what does that mean? Well, in terms of radius, a greater effect is going to draw electrons in closer to the nucleus, giving an atom a smaller radius. So if we want to know who has a larger radius, we look for the lesser effective charge, because a weaker effect will mean that the electrons won't be as close to the nucleus. They'll be farther away from the nucleus. So depending on how the question's worded, here we want to know who's larger. Well, I'd look for who has the lesser effective charge. And yes, aluminum's effective charge is less than that of sulfur, so it would have a bigger radius. How would we write that succinctly in one sentence? Well, since the effective charge of aluminum, and I quote numbers, is only 3, whereas that of sulfur is 6, aluminum's weaker effective charge would give it a greater radius. Very simple, very clean, succinct way to explain it. As another example, which has the larger radius, sodium or the sodium cation? Well, the first thing I would do would be to look at valence level. And sodium's a period 3 element, so it has n equals 3 as a valence level. Now remember, the sodium cation is formed by oxidizing a sodium atom, which only has one valence electron. And when that one valence electron is removed, it means the only remaining electrons at best are in the second energy level. So yes, sodium's valence level is actually n equals 2. And since valence level is always the first consideration in periodic trends or behavior, we could simply ask or state that sodium, by virtue of its greater valence level, I shouldn't say greater, I should say higher, it's farther away from the nucleus, has to have a larger radius than the sodium ion, which only has n equals 2. And that's how it should be worded. Given that the sodium atom has a higher valence level of n equals 3, quote the number, compared to that, I should say, of the cation, which only has n equals 2 as a valence level, sodium atom would have the greater radius. No fuss, no muss, simple way to explain it. Then, of course, what if we wanted to compare these two atoms? And I don't want to give away my answer, I want to be able to think. Which atom would have the larger radius and why? Phosphorus or its anion? Well, I start by considering valence level. This is a period 3 element, so n equals 3. This is also a period 3 element that's gained 3 additional electrons. However, those additional electrons are placed in the valence level, so it has the same valence level, n equals 3. Any difference? No, can't tell the difference. We then examine the effective charges of both atoms. And any group 5 neutral atom has +5 as an effective charge, but so would its anion, because its anion has no more protons than the neutral atom, and there are no more shielding electrons, non-valence electrons. Remember, the 3 additional electrons are valence electrons. So the effective charge is the same in both atoms in this example. So about the only difference we can see is that phosphorus does have neon's core, 3s2, 3p3 as a configuration, and the phosphorus anion has neon's core, 3s2, 3p6. In other words, the only difference I can see is that we have 8 valence electrons here and only 5 here. And a greater number of valence electrons would experience greater electron repulsion, and that would of course tend to expand them outward from the core electrons and from the nucleus. So the phosphorus anion has a larger radius. Succinct explanation, quoting numbers to inform the reader that I know what I'm talking about. Given that the phosphorus anion has 8 valence electrons, and the phosphorus atom only has 5 valence electrons, there is greater electron repulsion, key phrase, amongst the valence electrons in the anion, resulting in it having the larger radius. So we've covered all the cases there, but let's go back and think the other way. How should I phrase it if someone wants to know which has the smaller radius of these same groups we just looked at? And of course, if I'm looking for a smaller radius, I should think the opposite way, but in the same sequence. First, I think valence level, but to have a smaller radius, I'm looking for who has the lower valence level, not the higher one. Who's got their valence electrons closer to the nucleus? And then if I'm looking for a small radius, I want a great big effective charge, not a lesser effective charge. The big effective charge will draw the valence electrons inward. And lastly, if it comes to the final possible argument, if we want a smaller radius, we want less repulsion amongst the valence electrons, not more. We would want fewer valence electrons. So I would rephrase all of these if I were asking who had the smaller radius and why. For instance, magnesium would have the smaller radius because it has a lower valence level. So I'd say because magnesium has a valence level of n equals 3 compared to that of calcium's n equals 4, magnesium would have the smaller radius. Same reasoning, just the opposite way of thinking because we want to know the opposite thing. When I want to compare radius in an example where effective charge is the argument, I would pick the atom with the greater effective charge as having the smaller radius, because the greater effective charge brings the electrons in the valence level closer. So instead of what was written here for the largest radius, I'd say that sulfur has the smaller radius because its effective charge is +6, and aluminum's weaker effective charge is only +3. So sulfur would clearly have the smaller radius. If you're giving an argument that's based on electron repulsion only, I would of course use the opposite argument as well. If I'm looking for a smaller atom, I'm looking for less electron repulsion, and 5 electrons repel each other less than 8 would. So I would say because phosphorus only has 5 valence electrons, and yet the phosphorus anion has more, 8 valence electrons, there would be lesser electron repulsion, not greater, amongst the valence electrons in phosphorus, and that would give it the smaller radius. So don't give what I like to call antithetical arguments. If you're asked larger radius and why, think higher valence level, or think less effective charge, or think more valence electrons and more repulsion amongst them. If you're asked who has a smaller radius, think through the same sequence, but start with looking for the lowest valence level. That would have a smaller radius. Look who has a greater effect on the valence electrons, smaller radius. And see finally, if it comes to that argument, who has fewer valence electrons and therefore lesser electron repulsion.